hello everyone. Yes, my name is Amanda and I'm here to talk about content delivery at Spotify. If I haven't missed something this morning, I believe this is about the third talk about content delivery. So I see a trend. I will be taking some questions in the end of the presentation if we have some time, but otherwise you will be able to catch me during the social this evening, and of course during the coffee breaks and so forth. I have a background of computer and system science at Stockholm University. I work as a network engineer at Spotify since about 3 years back. Since about November, I work in a newly formed team entirely focused on content delivery. Prior to the formation of this team, I worked with Spotify's data centers and with some CDN and peering. So before we start off, I would like to mention a few things about Spotify itself, before proceeding to briefly explain what happens when you press play in the Spotify client. I will give you a glimpse into the Spotify control plane and how we use it to ensure good quality for end users. I will also talk about why we have pursued the notion of building our own CDN alongside the use of public CDNs. And of course, I'll mention some about our own caches. So I suppose you might have heard of a small little music service called Spotify. It's both a free and subscriber-based on-demand service with music, video shows, and podcasts. It's widely available in 60 markets with an active user base of over 100 million. Quite small, isn't it? So you got your Spotify client installed. What happens when you press play? I'm not going to go into the whole chain of events here because quite a lot happens, to be honest. But let's look about how the client fetches the requested content, because that's what we're here for, the content delivery. So when a client logs in, it will be given a set of URLs. These URLs are often public CDNs, and they are places where the client can fetch head files. Head files are a bit special. They are the first few seconds of a song entirely unencrypted. And they are there to serve a purpose and solve a real problem. To play a song, the client needs to exchange keys before it can play the song it's requesting. Thanks to the head file, the first few seconds of the song can start playing while other things happen in the background, making the playing seem instant, regardless of whether the song is previously downloaded and saved in the client or pre-cached. In other words, it's a mask for latency. Also, meanwhile, the head file is fetched. The client requests the control plane for another set of URLs for the actual set of files it wants, which in this case would be the rest of the song. These URLs, which the control plane responds with, points to entirely different CDNs, both public and private CDNs. So the control plane actually consists of several different services, but together they determine where to send our users. So what do we want the control plane to do? We wanted to hand out the URLs I mentioned earlier when a client plays a song, but not only that, we wanted to hand out the URLs in a clever way to make sure we utilize our private CDN. It all starts with the BGP sessions between the peer routers and a PMAC process. We use the BGP functions of PMAC in order to collect all the BGP routes learned through peering sessions on IXs and PNIs. These routes are collected and compiled into one global route table. And here we have swapped a few metrics around. For instance, we listen to AS path before med, before local pref. But this only happens over peering links. There is a little war story here that I might be telling you tonight if you're interested. So now we have all the routes, and we know who we peer with, but we need some more information for the control plane. We need to be aware of where our caches are. We also need to know the capacity of our links and what type they are. For instance, if they're transit or an IX link or a PNI. So this is information we just feed manually into the system. So we finally have our routes, our peers, location of our caches, the capacity of our links, and what type of links they are. And now we can let the system determine where to send the users as follows. Is there a cache in the area? Are we peering? What link shall we use? Links will be looked up in the following order with PNI, public peering, and then transit. Do we have resources in the cache? A PNI will always have priority over everything else in a cache. Do we have resources on the link? If any of the points on this list is answered with a no, the user will be giving a link to a public CDN instead. So I mentioned that the control plane takes resources into consideration. So how do we do this? We actually collect RPS, requests per second. And that's good enough for us to figure out traffic levels. Originally, we wanted to collect this information from the links on a network level. But we ran into some design issues with oscillation and feedback loops. But in practice, RPS turned out to work really great. A luxury we have as a content provider is that we really know our traffic. The result? So here we see a traffic curve, and this is not RPS, this is actual network traffic. The flat pillar you see to the far left is when this particular pop was intentionally set to a lower target utilization. So you can see how flat and nice the top of that curve is. So on to our next topic. Why build our own CDN? Public CDNs work well, and they have a worldwide reach. Our first metric is cost. By putting some of the traffic on our own CDNs, we can lower the cost of serving users. But another reason is to support growth, and this metric goes hand in hand with the cost. More users equals more traffic. So if we can put some of that traffic on our own CDNs, we're happy. Another reason is that we can be more in control of our content delivery. We can selectively route traffic where we want it, and we can have dedicated capacity. Also, that we can control exactly what we want to cache. We know our catalog better than a public cache. And this also means that we can fill our own cache with only our content. And having our own CDN finally also allows us to collect more data about our content delivery that we could, in an attempt to improve the content delivery. So our own CDN, they're built in partnership with Fastly. We use two different configurations from Fastly. And internally at Spotify, we call them a megapop and a micropop. All of our pops are connected to a peer router. This means that if you peer with Spotify, you peer directly with a cache. The micropop is just one server, but it manages to store most of our popular content. People actually listen to quite the same music. They might think they're hipster, but they really aren't. You'd be surprised. The Megapop is scalable and has more storage. Our configuration has 4 servers. It serves all music, so not only popular music. And that picture is not a picture from Bromma. Usually, you can see the actual caches in the bottom of the rack. Normally, they will have pretty red faceplates. They might be coming for this pop as well, I don't know. We're actually approaching the end of what I have to say today. But I do have some shameless self-promotion left of why you should peer with Spotify. Thanks to our control plane, you can ensure good quality of our mutual customers' Spotify experience. Also control, because we will do our best to accommodate your needs. We really want to make our peering partners happy. Peering with us will also lower Spotify traffic from public CDN. Keep in mind that if you peer with Spotify, you peer directly with a cache. I also want to show you this. This is a map of our current and upcoming CDN publications. We are present or to be present in all of these locations, so US, Europe, and APAC. So I was actually thinking if somebody had a question, maybe we could take that now. Some head scratching now. All right. So a little summary then. So we have a hybrid solution here with 1 private CDN and 3 different public CDNs. Right?
Thank you. Do you collect statistics for breakage from the client to? You had a few different ways and a few different URLs and so on. Does the Spotify client report this in, and you do analysis on that data so that you could tell if things are broken, how many times it has to go to the second URL or that kind of thing, and you map this and report that to ISPs, or is this data? Would be very interesting to know how well this works as an ISP, to know what the customer experience is.
Data is definitely collected, and essentially. What's important then with these files is that when a client fetches something and the response is the response timer is just really short. So the client times out super quickly if it doesn't get a reply. So we'll just move on to the next URL really quickly without end users noticing at all. And we do. I can't really think of how this is used really in monitoring or anything. I'm just thinking monitoring terms here. But all data is definitely collected.
Yeah, because it would be interesting if one thing persistently fails over time, that can be fixed. So that, and also if if one resource is constantly, I don't know, the latency is higher or whatever, to collect that kind of statistics, or if a customer has packet loss and it actually, all the connections are very slow or something like that, to understand that this is going on.
Yeah, that is something we could, for instance, figure out with that data. See if we see some persistent failures from an AS number to a cache, for instance, and that could be one of those situations where we would take the decision to send those users to another cache somewhere else, where they get better performance.
Yes,
And
that's working around the problem. What I'm talking about is showing that this path that we thought was the best path is not, and there might be a problem there. If you're constantly just working around it, it's never going to get fixed.
Oh, so you mean if we would have a conversation with a peer partner then and try to solve this?
If there is a channel, so if there is a way for you to tell the ISP that
yes.
constantly this path is always seems
Yes.
to work really badly.
Yes.
We're working around it. Customer doesn't care, but
Yeah.
you might want to look into that.
Yes, of course, of course.
Okay. Second thing, IPv6.
Yes, well, where is Mr. David Barroso? He's not here. Well,
Working on it.
yes.
Okay. Thank you.
Does anyone else have any more questions? Can we have a microphone over here, please?
Is this working? All right, cool. Hugge, Nordnet. So, I mean, I guess regarding the IPv6 thing, will you not be able to do V6 before Fastly does it? Because I know that Fastly is a bit behind on V6. Is these solutions so tightly tied together that they don't work? I mean, you can't. They have the same feature train essentially, or since this is an in-house Fastly type of CDN or Fastly style CDN, or how is the relationship really here between Spotify CDN and Fastly CDN?
Well, they essentially build their caches, and they're also the systems of how they work, sort of. So.
Right, so that means when Fastly has V6, Spotify has V6.
V6, yes.
All right, cool.
That's a little bit how it works.
Do we have any more questions? We've got a little bit more time for Amanda. Anyone got anything they want to ask? V6 related or otherwise? No? Okay, well, thank you very much. Please thank Amanda for us.